Welcome to Chapter 5, Section 4. We're doing Example 3. This is an application problem using the slope formula. All right. A lot of real-life situations are not lines. Okay? I'm going to speak truth to you. A lot of real-life situations have the graphs of them when we compare a set of data to another set of data. We do not get a straight line. In order to understand those situations, first we start with what's easy. That's where the lines come in. That's where the linear functions come in. However, there are a lot of situations that are lines. This is a situation where water is draining out of a water reservoir. Okay? So for a lot of cities, and especially cities that aren't next to lakes or rivers or anything. I think St. Paul gets most of its water from the Mississippi River, which would make sense. And then it goes through like a water treatment plant, and then that way it goes to your house. My home state of Indiana, Indianapolis is not on any major lakes or major rivers. So they have water reservoirs, and the one that I know of is the Eagle Creek Reservoir, which is kind of cool. So it's a place where they built up basically a man-made lake, and that lake water is used for the water for a city. Okay, look it up. It's really cool stuff. Seems that the water in this reservoir is going down. So we're studying it over a 60-hour timeline. Okay, when we started studying it, it looked like there was 5, 10, 15, 20, 25, 30, 3,500,000 cubic feet of water. Okay? And by the way, cubic feet is not a gallon. So you'd have to look up the conversion for it. That's why the metric system is so much better. Anyway, but after 20 hours, it's now gone down to only 3,000. And after 60 hours, it's now gone down to 2,000. It seems like the water is draining out of this reservoir at a constant or steady rate, and we need to find that slope. First of all, I know it's going to be negative. The line is negative. The negative simply tells me you cannot measure water with a negative number, okay? The volume of the water in cubic feet has to be positive. The negative simply means that the water is draining away out of the reservoir. So that's why it's going down, all right? When we use negatives, usually it means the direction that we are going, all right? My 2 points that I have here, and I could pick other points along this line, but the 2 points that I have here are 20, 3,000, and 60, 2,000. Let's find the slope. Now, this is my first x, this is my first y, this is my second x, and this is my second y. So I'm going to find the difference of the y's. y2 minus y1. 2,000 subtract 3,000. Now, since 2,000 is smaller than 3,000, I'm going to get a negative number. That negative number, like I said, you don't have negative hours, you don't have negative volume, but the direction that the rate is going, is negative. That means it's going down. For difference of my x's, I got 60 subtract 20. Do a little subtraction, I get negative 1,000 divided by 40. And if you want to grab one of these, probably can't see it, sorry, had the cover on. If you want to grab one of those, that's fine. To be honest, you can actually do this one in your head. If I cover up the zeros, 100 divided by 4 is 25. So this is going to be negative 25, and let's use our units, 1,000 square feet. And what that means, or cubic feet, excuse me, what that means is that instead of me putting a bunch of numbers after this, we're just using the smaller numbers by saying that means 1,000. I could also write it like this. Well, that might actually be confusing with that, so I just changed my mind on that. Divided by 1, which is hour. So this is a unit rate. So it's going down negative 25,000 cubic feet per hour. So what does the slope represent? It represents the volume of the water that is leaking or being pumped out. I don't have a story here, okay? But it's the volume of the water that the reservoir is decreasing by for each hour. And notice what I did here, okay? Remember that the slope or the rate of change is the change in y over the change in x, okay? This is the independent variable. This is the dependent variable. How do I know what the independent and dependent variables are? They're on my graph. So this is the x. That's why I say per hour. This is my y. And in this case, this is time measured in hours, and this is water, volume of water measured in cubic feet or thousands cubic feet. So remember the word per means divide. So it's this label divided by that label. See you in the next video.